everyone. So up until now, we've learned about 3 different fractions or conversion factors that we can use in our T-charts. So the first one we've learned about was molar mass. Now remember, you can figure out the molar mass by using your periodic table. And when you write it, it's always going to be molar mass, like whatever you calculated, next to grams, and it's always equal to 1 mole of whatever chemical you have. Avogadro's number is not a calculation, it's just a number. You can find it on the back of your periodic table, but it's 6.02 times 10 to the 23 particles, and it is also equal to 1 mole. Now, the word particles, that unit, can be swapped out for the word atoms, molecules, or formula units, okay? So those all 4 words can be put there next to Avogadro's number. Mole ratio is the one that we learned about in our last lesson, and this comes from our chemical equation, okay? So if you don't have a balanced chemical equation, you can't find your mole ratio. And it comes from using your coefficient, which is the number of moles of chemical A, and then the coefficient, which is also moles of your second chemical, which we'll call chemical B. Now, the thing about this is they each have clues indicating when you need to use them. For molar mass, it's grams. If you ever see grams, you need that fraction. For Avogadro's number, it's the word atoms, molecules, formula units, or particles. If you see any of those 4 words, you will need Avogadro's number. For mole ratio, it's when you have different chemicals. So if what you're given and what you're trying to find in terms of your chemicals, if they're different, then that means you need mole ratio. And so we just use them in different combinations. So we're going to look at 2 different types, okay, of problems. So the first one, we will do this problem here, okay? It says how many grams of zinc are needed to react with 1.5 moles of silver nitrate, okay? So when we label what we're given and what we are trying to find, we see that we are given in the problem 1.5 moles of silver nitrate. And it says that we're trying to find, so it says how many grams of zinc. So we have grams of zinc. Now, we look for some of our clues. Molar mass, the clue is grams. Do we have grams? We sure do. We see this. So that means I will need the molar mass of zinc, which is the chemical that's right next to it. We don't see the word atoms, molecules, formula units, or particles, so we know we don't need Avogadro's number. But we do see that silver nitrate and zinc are 2 chemicals. They're different, and so that does mean that we'll need to use our mole ratio. So if we write those out, okay, so let's write out, okay, what is my mole ratio for this problem? Our mole ratio, as our notes said from above, come from our chemical equation, our coefficients. So we have zinc and silver nitrate. The coefficients are a 1 and a 2. So my mole ratio can be written as 1 mole of zinc over 2 moles of silver nitrate. And in our T-chart, we could flip them if we need to cancel out the units with the flipped version. Okay. Now, we said we also needed the molar mass. The molar mass of zinc is just 1 element, so that would be 1 times our mass of zinc, which is 65.38. So that gives us 65.38 grams of zinc over 1 mole of zinc, because our molar mass is always over 1 mole, or we can flip it. Okay. Now that we have figured that out, we can set up our chart. The first thing that goes into our chart is our given, 1.5 moles of silver nitrate. Now, you might say, okay, I know I need mole ratio, I know I need molar mass, but which one do I use first? You always base it on your units. So since I have moles of silver nitrate here, and that's not what I want to end up in, I'm going to have to put them in the denominator in order for them to cancel out. So we move forward by determining what will cancel out my units. And we can see that the only conversion factor that has moles of silver nitrate in it is our mole ratio. And it's actually conveniently already on the bottom. So we put our 2 moles of silver nitrate here and our 1 mole of zinc at the top. Now, moles of zinc is not what we're trying to find. We're trying to find grams of zinc. So that means we'll need to cancel out moles of zinc. So we set up a second step, which is great because we already said we would need 2 steps, mole ratio and molar mass. So because moles of zinc is here, it must show up in the bottom. Okay, that's always the pattern. So moles of zinc. Now, we've already used mole ratio, so we can't use it again. So what we'll use is our molar mass, our 1 mole of zinc for every 65.38 grams of zinc. And we can see that grams of zinc matches what we're trying to find, so we know we're done and we can put things into our calculator. So we always start with our 1.5 and just multiply across the top. Times 1 times 65.38, and then we divide by anything at the bottom. So divided by 2, divided by 1. And when you put this in your calculator, you should get 49.0 grams of zinc. Okay. So these type of problems are ones that we would call 2-step problems because we put our given into our T-chart and then we had a first step, so step 1, and then we had step 2. Okay. Now on the back of your notes, or in the next section, we're going to have mass to mass, where we're changing from grams of one chemical into grams of another, and these are considered 3-step problems, but they follow the same process that we've done the whole time. So what I'm going to do is I'm actually going to do letter B because its coefficients are a little more interesting. Okay, so let's go ahead and label what we're given. So we are given 165.0 grams of NaOH, and what we're trying to find, it says that we're looking for grams of sodium aluminate, okay, or Na3AlO3, right? So we look for our clues. The clue for molar mass is grams. So I see grams in 2 different places. So here, this means the molar mass of NaOH. And then this one means the molar mass of sodium aluminate. Okay? And then we know that we don't see molecules, atoms, formula units, or particles, so we do not need Avogadro's number, but we do have different chemicals here. So if these are different, that means we will need our mole ratio. Okay. Now, the beauty of this is if you actually show out your work this way, what you'll find is this will be step number 1, step number 2, and this will be step number 3. And you can confirm that because your units should cancel out properly. So what we'll do is we'll go ahead and figure out what each of those things are. That way plugging in our T-chart is very simple. So the molar mass of NaOH, so we have sodium, oxygen, and hydrogen. We have 1 of each, and we multiply by their mass on the periodic table. Sodium is 22.99, oxygen is 16, and hydrogen is 1.01. So since multiplying by 1 doesn't change anything, they stay the same. And when we add it together, which I'm going to show it a little differently, when we add them all together, we get 40.00 grams of sodium hydroxide over 1 mole of sodium hydroxide. Okay, so that's perfect. That's our molar mass. our mole ratio comes from our coefficients. So we know that we are looking at sodium hydroxide and sodium aluminate. So those are the only two we're really worried about. We can put our 6 moles of NaOH, and we can put our 2 moles of sodium aluminate on the bottom, okay? And then we also need the molar mass of sodium aluminate, which I'm going to do up here. So we have sodium, aluminum, and oxygen. We have 3 sodiums, 1 aluminum, and 3 oxygens. So we multiply by their mass on the periodic table. Sodium is 22.99, aluminum is 26.98, and oxygen is 16. So 23 times 22.99 is going to give us 68.97. This will stay the same. And 3 times 16 is 48. So when we add them all together, we get 143.95. So that means this molar mass could be written as 143.95 grams of sodium aluminate all over 1 mole of sodium aluminate. Now, you don't have to write this out every time, but a lot of you are making simple mistakes that if you were to do this step exactly the way I've shown it to you, it might take longer, but you're going to make fewer mistakes. Okay, so if you've been practicing it and you've been doing this a lot and you've been getting them right every single time, maybe you could cut that out. But right now, I don't recommend it. So we can now set up our T-chart, okay? And we always put what we're given first. So we have 165.0 grams of sodium hydroxide. Now, we do not want to keep grams of sodium hydroxide, so we follow our pattern. If I have grams of sodium hydroxide here, it has to show up at the bottom. Grams of sodium hydroxide. Now, when we look at our T-charts, the only place that you see grams of sodium hydroxide is right here. So that means we'll be using our molar mass, and we'll have to flip it so that the grams are at the bottom. So we'll put our 40 grams at the bottom and my 1 mole of sodium hydroxide at the top. Now, moles of sodium hydroxide is not what we're looking for, so we're going to have to keep going. So again, we need to cancel this out, get rid of them. We don't want to keep them. They're not what we're trying to find. So that means that moles of sodium hydroxide must appear at the bottom. Now, we've already used the molar mass of sodium hydroxide, so we can't use it again. So out of all the ones that are left, only our mole ratio has moles of sodium hydroxide in it, and so we're going to have to flip it. So we're going to put 6 moles of sodium hydroxide at the bottom and our 2 moles of sodium aluminate at the top. Now, we need sodium aluminate, that's what we're trying to find, but we need grams, not moles. So that means we have our third step, and we take moles of sodium aluminate, and it must go at the bottom in order to cancel out. It's a great way to check your work. Make sure that your units are following the diagonal pattern so that they cancel out. Now, again, we've already used our mole ratio, so we can't use it. That only leaves us with one option left, and it has moles of sodium aluminate at the bottom, which I realized somewhere along the line I put a 2 instead of a 3, but that should be a 3. So we'll put our 1 mole of sodium aluminate there and 143.95 grams of sodium aluminate at the top. And because these grams of sodium aluminate matches what we're trying to find, we know that we can stop and put it in our calculator. So again, the first thing that goes in our calculator is our given. So it's 165.0 times 1 times 2 times 143.95, and then we divide by what's on the bottom. Divided by 40, divided by 6, and divided by 1. And when you put this in your calculator, and all of you should be practicing that now, you get 197.9 grams of sodium aluminate as our answer. So it's literally the same pattern over and over again. It's just different combinations of these three things here. So please, please, please make sure you're practicing.